twice now, we've told you a dinosaur almost certainly had feathers, without a single feather ever actually being found on that specific animal. Deinonychus, probably feathered. Utahraptor, probably feathered. Both conclusions borrowed from close relatives, not from direct evidence on the animals themselves. This time, that problem doesn't exist. In 2012, a team led by paleontologist Xu Xing described a dinosaur with feather impressions preserved directly in the rock, not inferred, not borrowed. Physically there, on an animal that had absolutely no business having them, according to almost everything paleontologists thought they understood about feathered dinosaurs up to that point. It weighed somewhere in the neighborhood of 40 times more than any other feathered dinosaur known at the time. And its existence kicked off a debate about Tyrannosaurus rex that, honestly, hasn't fully resolved itself in the direction most people assume. The fossils came out of the Yixian Formation in Liaoning Province in northeastern China, a site that's produced some of the most spectacular feathered dinosaur discoveries anywhere on Earth, dated to roughly 125 million years ago, the Barremian stage of the early Cretaceous. 3 individuals were recovered, purchased from a fossil dealer rather than pulled from a controlled excavation, which is worth flagging honestly, since it means the exact original stratigraphic details rest on second-hand information rather than direct field documentation. What the 3 skeletons represent, though, is unambiguous. 1 adult, cataloged as the holotype, and 2 smaller individuals at different growth stages, roughly 8 years younger by the team's estimate. Xu Xing, working with 8 co-authors, published the formal description in the journal Nature in April of 2012, and gave the animal a name that describes exactly what made it remarkable. Yutyrannus, combining the Mandarin word yu, meaning feather, with the Greek-derived tyrannos, meaning tyrant, feathered tyrant. The species name, huali, is Mandarin for beautiful. Yutyrannus huali, the beautiful feathered tyrant. Here's why that name mattered as much as it did. Before this discovery, every confirmed feathered dinosaur was small, genuinely small, in most cases lightly built, the kind of animal you could reasonably picture actually being covered head to toe in a coat of fuzzy insulation without straining credulity. The largest confirmed feathered dinosaur at the time was Bapiosaurus, an animal we actually mentioned all the way back in our very first video on this channel, a therizinosaur weighing somewhere around 85 kilograms. Yutyrannus's adult holotype has been estimated at roughly 9 meters long and around 1,400 kilograms. Some estimates run slightly higher, some slightly lower, which is normal for mass calculations built on incomplete skeletons. But even taking the more conservative end of that range, you're looking at an animal reported at somewhere around 40 times heavier than the previous largest feathered dinosaur on record. For comparison, it was still only around a fifth to a sixth the mass of a full-grown Tyrannosaurus rex, so this wasn't the biggest predatory dinosaur that ever lived by any stretch. It was, at the time, simply the biggest one anyone had ever found direct feather evidence on, by an enormous margin. And to be clear about what direct feather evidence actually means here, because it's worth being precise rather than just repeating the headline. These weren't the large, veined, structurally complex feathers you'd picture on a modern bird's wing. What was preserved were long, simple filaments, some measuring up to about 20 centimeters, structurally closer to fine, hair-like down than to anything resembling flight feathers, the kind of primitive feather type that shows up early in feather evolution before branching. Veined structures developed. The preservation quality wasn't good enough for the original team to determine whether individual filaments were simple strands or slightly more complex branch structures. And that's a real limit on what the fossils can tell us, not a minor technicality. And the coverage wasn't uniform across all 3 skeletons either. On the adult holotype, feathers were preserved around the pelvis and near the foot, along with feathers on the tail angled backward at roughly a 30-degree angle. On the smallest, juvenile individual, feathers turned up instead on the neck and upper arm. No single specimen preserves feathers everywhere at once. The conclusion that Yutyrannus was likely feathered across its entire body is a reasonable inference, built from combining evidence across 3 different individuals that each preserved feathers in different spots. But it is an inference, and the original researchers themselves were upfront. that an alternative explanation, feathers limited to specific display regions rather than full body insulation, couldn't be entirely ruled out from what actually survived in the rock. Now, here's where this story runs directly into the question everybody actually wants answered the moment they hear about a giant feathered dinosaur. Does this mean Tyrannosaurus rex was feathered too? The honest answer starts with where Yutyrannus actually sits on the family tree, because it's further from Tyrannosaurus than the popular framing usually implies. Xu Xing's original 2012 paper described it simply as a large basal tyrannosauroid, more advanced than a few even older relatives, but still fairly early diverging. A more detailed 2016 analysis by Bruce Sate and Carr placed it specifically within Proxuratosauridae, an early branching family within the broader tyrannosauroid group, alongside a dinosaur called Guanlong. Some later analyses quibble over the exact fine placement within that family, but every version agrees on the part that actually matters here. Yutyrannus sits well outside Tyrannosauridae, the specific family that actually contains Tyrannosaurus rex, along with close relatives like Tarbosaurus, Albertosaurus, Gorgosaurus, and Daspletosaurus. It's outside the tighter group of derived, large-bodied tyrannosauroids, most closely related to T. rex as well. So, Yutyrannus having feathers tells us, with genuine confidence, that feathers existed somewhere in the broader tyrannosauroid lineage, roughly 125 million years ago. It doesn't, on its own, tell us anything directly about what was covering Tyrannosaurus rex's skin more than 30 million years later, on a completely different, much more derived branch of that same family tree. For that, you need actual fossil evidence from Tyrannosauridae itself, and as it happens, that evidence exists, and it points somewhere most people don't expect. In 2017, a team led by Phil Bell published a study in the journal Biology Letters built around a specific Tyrannosaurus rex specimen nicknamed Y-Rex, recovered from the Hell Creek Formation in Montana, currently held at the Houston Museum of Natural Science. Y-Rex preserves actual fossilized skin, patches on the neck, the pelvis, and the tail. The only direct skin evidence recovered from Tyrannosaurus rex anywhere, as far as current records show. What that skin shows is smooth, unornamented scales, arranged in a distinctive branching pattern researchers describe as resembling a leaf's midrib and veins. No feathers, no feather-adjacent structures at all, anywhere those specific patches were sampled. The same team also reported new, previously undocumented scale evidence in Albertosaurus and Gorgosaurus, plus additional data from Daspletosaurus and Tarbosaurus, and found scaly, unfeathered skin consistently across the neck, torso, hips, and tail in every one of these large, derived tyrannosaurids sampled. One Albertosaurus specimen even preserved raised, ornamental scales on the abdomen, a distinctly reptilian feature, not a feather-adjacent one. Their statistical modeling suggested filamentous feathers were most likely the ancestral condition across tyrannosauroids as a whole, consistent with what Yutyrannus shows us. But that same modeling indicated this feathered covering had already been lost, somewhere at or before the base of Tyrannosauridae itself, well before Tyrannosaurus rex ever showed up in the fossil record. It's worth being fair about the limits of even this evidence, rather than swinging all the way to the opposite overcorrection. Every skin patch recovered from Y-Rex and its tyrannosaurid relatives comes from the neck, torso, hips, and tail. Nobody has ever recovered skin from the upper back of a large tyrannosaurid, so a partial feathered covering along the dorsal midline technically can't be ruled out by this evidence alone. And nothing here directly tests whether very young Tyrannosaurus rex individuals might have carried some kind of downy covering that was shed later in life, the way some modern animals lose juvenile coats as they mature. The researchers themselves call that scenario hypothetically possible, while noting there's no direct fossil evidence supporting it either. So the fair, current summary isn't T-Rex definitely had no feathers anywhere. It's that every single patch of actual T-Rex skin ever found is scaly, across multiple different body regions, and multiple different closely related genera, and that the popular image of a fully fluffy, downy Tyrannosaurus rex that spread through documentaries and museum art in the years after Yutyrannus' discovery runs directly against the best direct evidence currently available. Which raises an obvious question. If feathers were the ancestral condition for this whole family, and Yutyrannus, sitting further back on the tree, kept them at a genuinely enormous body size, why would later, larger tyrannosaurids have lost them? The first explanation offered, back in 2012, was climate. The Yixian Formation environment where Yutyrannus lived appears to have been notably cold for the early Cretaceous. Independent paleoclimate research backs this up. A 2011 study analyzing oxygen isotopes from East Asian dinosaur fossils estimated mean annual temperatures around 10 degrees Celsius for the region, genuinely cool for the era, and a later 2021 study focused specifically on the Yixian Formation's Saihetun locality, tied to unusually high elevation, estimated an even colder average closer to 6 degrees. Corwin Sullivan, one of the original paper's co-authors, suggested directly that a tyrannosauroid of similar size living later in a warmer late Cretaceous climate might simply not have needed feathers the way Yutyrannus did in a genuinely cold environment. It's a clean, intuitive explanation, and it's the one that ended up repeated most often in popular coverage. Except the very same 2017 study that documented T-Rex's scaly skin directly tested that explanation and rejected it. Bell and his co-authors pointed out that estimated temperatures for the late Cretaceous localities where large tyrannosaurids actually lived, in North America and Mongolia, come out comparable to the Yixian Formation's climate, not meaningfully warmer. If the environments were roughly similar in temperature, climate alone can't explain why one lineage kept its feathers, and a later, more derived lineage lost them. They also noted that other feathered dinosaurs living alongside the tyrannosaurids in those same supposedly warmer, late Cretaceous environments didn't undergo the same kind of feather loss, which further undercuts a simple, climate-driven story. Instead, the paper raises a handful of alternative, competing explanations, none of them confirmed. Gigantism itself and the basic physics of how larger bodies shed heat less efficiently relative to their volume, though they note this gets complicated once you actually compare body masses directly, since Yutyrannus, at around 1,400 kilograms, was actually smaller than several of the scaly tyrannosaurids in their own sample, including Gorgosaurus and Tarbosaurus. A difference in activity level, with more cursorial, higher energy-derived tyrannosaurids needing better heat dissipation than their ancestors. Or simply habitat, open, exposed, late Cretaceous environments potentially favoring less insulation than a more sheltered, forested early Cretaceous ecosystem. The same basic pattern you see today comparing megafauna that live in open plains against similarly sized relatives living in dense forest cover. The researchers themselves describe this as a genuinely counterintuitive, unresolved pattern, one that can only be settled by future fossil discoveries, not by anything currently in hand. As of the most recent research available, nobody's published a direct answer. There's a piece of more recent context worth adding here too, even though it doesn't resolve the feather question directly. In June of 2025, a team led by Voris formally described Conchulu mongoliensis in the journal Nature, a horse-sized tyrannosauroid from Mongolia, estimated at somewhere between 500 and 800 kilograms. Dated to roughly 90 to 83 million years ago. The fossils themselves weren't newly dug up. They'd actually been sitting mice-identified since the 1970s. But the redescription placed this animal as the closest known relative to the ancestor of the entire lineage that would go on to produce Tyrannosaurus rex and its closest relatives, and it formally clarified the specific name for that derived group, Utahraptoria. It's a genuinely useful marker for placing Yutyrannus in context. Roughly 125 million years ago, you have a genuinely giant, confirmed feathered tyrannosauroid. Somewhere around 90 to 83 million years ago, you have a smaller, horse-sized relative, sitting right at the base of the lineage that leads to the giants everyone actually recognizes. And by the time you reach Tyrannosaurus rex itself, in the last few million years of the Cretaceous, every direct skin sample recovered says scales, not feathers. Whatever happened to this lineage's feathers happened somewhere in that long stretch in between, And right now, nobody can point to the fossil that pins down exactly when. One more honest gap worth naming before we close this out. Unlike some other spectacularly preserved Jehol biota dinosaurs, like Sinosauropteryx, which had actual pigment-producing structures called melanosomes recovered well enough to reconstruct probable coloration, no equivalent study has been published for Yutyrannus. We genuinely do not know what color this animal's feathers were. Reconstructions you'll see online showing specific color patterns are speculative, artistic choices, not findings backed by direct evidence, and it's worth being upfront about that, rather than presenting someone's illustration as settled fact. So, where does Yutyrannus actually leave things? It proved directly with fossil evidence, rather than inference borrowed from a smaller cousin, that a dinosaur could carry substantial feathering at a body size nobody expected feathers to survive on. That's a real, settled finding, and it rewrote assumptions about the relationship between body size and insulation in this entire group of animals. What it didn't do, despite how the story got told in a lot of popular coverage over the following decade, is prove that Tyrannosaurus rex itself was feathered. If anything, the best direct evidence currently available, actual fossilized T-Rex skin, says the opposite, at least for the specific patches anyone's ever found. And the honest, current scientific position sits in the gap between those two facts. Feathers were ancestral to this whole lineage. They were lost somewhere before Tyrannosaurus rex arrived. Nobody's found the fossil yet. That explains exactly why, or exactly when. All right, that closes out this run of dinosaurs, 3 in a row now, so it's time to head back into the water for a bit. Next time, we're covering an animal most people have never actually heard of, despite it very possibly having been a bigger, more dangerous predator than the one everyone has heard of. Livyatan melvillei, a giant prehistoric sperm whale with teeth larger than anything found in a megalodon's jaw, discovered from a skull dug out of the Peruvian desert, and the real question of which one of these two animals was actually running the show when they shared the same ocean. That one's next. Let me know in the comments what you want catalog after that, and subscribe to Claw Catalog so you're here for it.